recording is on. Let me go ahead and just do the introductions, and then let's carry forward. Again, this will all be recorded. So hello and welcome to part 2 of the Good Design is Good Business series on DeveloperWorks designing Java refactoring and designing for testability. Part 2 today is specifically on refactoring for testability, and our speaker once again is Ken Brittain, programmer at Computer Sciences Corporation, and you can reach Ken at any one of those at either email or Twitter links that you see there on your homepage for the web conference. Today's web conference is being recorded, so if you do not approve, please disconnect now. Otherwise, this recording, along with the other parts of the series, will be uploaded to the links on DeveloperWorks. Eventually, they're on YouTube, but those links will get you there as a landing page. And without further ado, Ken, thank you for once again hosting today. Good working with you, and I'll pass control over to you right now.
Okay, thanks. Thanks for having me. Welcome, everybody. Last time we talked about using JUnit and some of the patterns associated with unit testing. We talked about using the annotations, some naming things, how you're testing. We talked about dependency injection and things along those lines, that if you had a code base that was brand new, some greenfield development, it's nice. You can start writing it using those concepts and your code. And if you did a test-driven development model, all of your code would be arguably testable. However, we all don't get that unique privilege of starting on a brand new project all the time. So talking about today, refactoring existing code to make it testable. Specifically, we have large code bases that were written under, we'll call them dire circumstances, scheduling for whatever reasons, and things were done in a quick-to-get-running manner, not a testable manner. So the particular project that I'm working on was written under a time frame, and a lot of the code was generated. It was generated in such a way that it was very, very untestable. So now we have a large application that we have difficulty creating unit tests for to test any of the functionality in the application. So we need to come up with a framework of how we're going to figure out what we're going to write unit tests for, because it's great to say everybody has to write a unit test. For new code, we do that. We use a test-driven development model. You write your test first. You write your code. You go back and forth, and your unit tests are the first client of your code. Then you put it into your framework and a little bit of integration, and everybody's happy. But when you say go in to fix an issue in an existing product, we require you make a unit test of that. Why? Because that way, moving forward, we won't be caught with that same bug, in a regression later on. If we have a unit test, we can run it. The issue comes in when you can't test your code. You can't test your code for various reasons. So we need to identify what classes that we're going to write unit tests for, because it's not as simple as sitting down and, for new development, and you just start writing your unit tests as part of your coding. When you're retrofitting unit tests to code, there is work that needs to be done on top of the unit test itself to make the existing code base testable. So today we're going to be talking about identifying those classes, how I've done it in the past, and how we're starting to do it today with the help of some tools to give us more confidence that the classes we're going to be modifying are the classes that we want to be modifying. And then we're going to cover some of the patterns that we work with daily in creating those unit tests where we refactor an existing code base to make it testable.
Yeah, and that that confidence that you talk about it can, from the business standpoint, can also translate into faster time to market. And I know we all want to write the best code possible, and having some ability to do this kind of level of testing gives us not only confidence but a better way to deliver the software faster to the business.
Right. My big push lately has been that confidence factor for this whole unit testing, applying unit tests to an existing code base in which they don't exist. From a management perspective, they're not so thrilled with, suddenly every project you do taking 25% longer, or, pick your number. But if you can identify classes, and we'll get into this later, that need to be refactored, that need to have this testability worked into it, and give them some measurable metric of why you chose it. There's always the code in a project that somebody will say, oh, that code's horrible. It's always been bad. Nobody wants to deal with it. But it's another thing to give them, or when I say them, I mean management, because they're in essence paying for all of this. They need something that says, here are the things we've identified, and here's why we have identified them. And we'll get into that when we start talking about the volatility. So we need to identify our classes. The two words that we like to use are volatility and toxicity. Volatility really means, how much is something changing? Toxicity is, how bad is it? These two words actually kind of formed from a blog post we read sometime this year. Before that, we used to call it the things that change a lot and the things that's really bad. But now we like using these two words because it sounds much more professional.
Yeah, any of the illy and itty words.
Yeah.
Give it more official.
Exactly. Like I said, there's toxicity. We always know there's certain pieces of code that are just really, really bad. There's bad things done to them. They were rushed. They have a lot of defects in them. Toxicity sounds so much better than that. It's less opinionated. So now we use volatility and toxicity. But volatility is really just your code, the code base, changing over time. So you do a series of check-ins. You're working on a project. You have changes that go in, fixes that go in, and new functionality. Your version control system can give you a report of the project you're working on. You can produce a report that says, here are what we like to look at as a number of changes, not check-ins, because you can get, the diffs and figure out what changed. So we can get a report, and it tells us what classes, because we're in Java here, are changing the most on a project. From our perspective, that gives us the volatility, the things that change the most. If we're changing things a lot, that means there's something either wrong with it or that we're adding a lot to it. And that's just a metric that we use to get that information out. One of the things we definitely look for is if you have a framework and you're changing base classes, things that should have been fixed or not being worked now, and they keep changing on a weekly basis, on a build-per-build basis, you want to know about that sooner than later, because it definitely brings out some deficiency in your framework. We were working on a project, and we did have our framework for error handling, logging. The project was based on struts, standard, web-type project. And as we're approaching release, we started to see a lot of changes in classes that should not have been touched. They were part of the framework. They were ironed out a long time ago, and things were changing very rapidly. So in our report, which I said is just a simple report that you run from your version control, you can always get your CM guys to help you create that if you don't have the privileges or the proper client, which is what we did. And so they gave us the report that we want, and we can just run it at any time. So we do a build, we run the report, and we start noticing that some of the classes, base level classes in our framework for our web application were changing. And that was our first clue that something was wrong, because we're supposed to be developing functionality here, not developing the framework. That was set a while ago. So that was a big cue that something was definitely happening in the wrong way. Now,
good point, Ken. If I can just, I wanted to ask a question about what role in a project are you seeing should be monitoring that type of thing? Is that the project manager? Is that the lead architect, lead programmer? I mean, who should be watching that, those reports, or something like a dashboard in Team Concert, for example, or ClearCase? Who should be watching those?
Yep. In our scenario, it's the technical team lead, because they're responsible for the, obviously all technical aspects of the project. They need to know everything. In this case, that was myself. And once you start seeing that information, you know what's going on. If you weren't, if you were, say, a product manager, perhaps not as technical, you could see the information, but you wouldn't understand what was going on, because per build, yes, a lot of things were changing. So if you're just looking at raw numbers, you're going to get a big, change list. But it's really what is changing that is critical at this point. So I would say the technical team lead or comparable role is somebody who needs to monitor that situation. And we do it per build.
Excellent. Thank
you. No.
Thank you. And just to let the audience know, we will open up the lines for questions a little bit later. But right now we're in a moderated session. But we'll announce when we'll open up for questions. If you do have a question before we open up the lines, you can use the webcast chat window, which is the furthest on your right to where the attendee list is, right of the slide. So thanks, Ken.
So the next thing that we use, because ours is a web application, and we have it set up such that each page, when it's rendered, these are JSPs, we have, notification of that in the log. So we know how long a page took to load, to render, not load in the client, but render on the server. So that gives us a clue as, you could picture building a spreadsheet of times. And I have done that at times to prove certain points. But for this case, we were looking at pages and find out, usage patterns. What are our most popular pages in our product? What does the client do on a regular basis? Because if you have something that's changing a lot and nobody uses it, that's a big indicator that this is, a waste of time to be doing. What we use our web logs for, we call it the popularity factor. We want to focus our refactoring efforts, because we don't have unlimited time or unlimited budget, on things that give us most bang for the buck. And the most bang for the buck comes in with pages that the client uses on a regular basis. If the client's not using these pages and we're fixing them and writing great unit tests for them, nobody's really going to care other than the developer. We don't have a strict unit test coverage guideline parameter where we say, we're shooting for 80% unit test coverage of all of our classes. We don't do that, because the project is very big and we are retrofitting these unit tests into the project. So to write tests for test's sake is not necessarily what we want to do. What we want is to focus our efforts on the most popular, the things that people use. And that gives us, like I said, great buy-in from management, because we're not going off trying to create, some magical unit test framework that will magically improve the quality of the entire product. We're saying, here's a report, here's classes that are being changed. These affect, the top 10% of the pages. We need to definitely work on those, make them more testable, so that next time we visit this, we'll have a full unit test suite to take care of the quality issues, so there are no regressions going forward. Another thing that we do, which is related to the unit test, is we have a full regression test, which we use Selenium to go into the browser from a client level and test. So anytime somebody does a project or fixes a defect on a page, we have a unit test for the code, and we have a regression test that goes in from the client level to actually test the functionality. And this is all done before it goes into our integrated testing environment to be tested by our QA professionals. So this is done at the developer level to help us keep that quality level high. So from a volatility perspective, we're looking at the classes that are changing the most and they're most popular, meaning they're used in pages that people like to visit and perform functions from, because that's going to give us the most bang for the buck. So now we'll move on to toxicity. And previously this was, like I said, just the stuff that had a lot of bugs in it. We knew it was broken, but we had no quantitative way of saying what was wrong with it. There were defects. You could point to a defect report. It goes back to a page. The page could, talks about servlets, actions, but there was nothing that, from a management perspective, that they would go, oh yes, we need to spend time to do that, because there's just the anecdotal evidence that this subsystem is not up to par, and they didn't want to spend time and the money to write, like I said, these blanket unit test coverage over. Sorry, my screen just died for a second. They didn't want to write unit test coverage to a unit test coverage parameter for no apparent reason. So what we did, and this was taken out of, it's in the resources, there's a tool that comes up with what they call a toxicity chart, and that's where we got the name toxicity from. And the toxicity chart, we use known defects. We have a bug reporting system. People enter bugs. We can categorize them. We can associate them with pages. Pages we can then, from a developer perspective, group into a subsystem and take it down to a class level. So we know, based on a report from our bug system, what systems have the most issues. The interesting part came in with this tool, and like I said, it's in the resources section. You can go in. The tool is check style, and it will run over your code base, and it produces a chart, an XML file that you load up in Excel, and you get a series of information. What it's looking for are a series of metrics based on code size, method size, cyclomatic complexity. They have a whole bunch of other ones that we're not necessarily, in our case, we're not specifically calling them out and configuring them. We're using them as a standard package that they have written, but it gives us a measurable quantity for our code. So now, in terms of toxicity, we have a candidate selection list of classes that we know have some issues. And then if we run our report, we can get a candidate list of issues, potential issues. And where those two meet is where we actually focus our unit testing muscle. That's where we focus our bang for our buck. The management likes it a lot better than, like I said, this subsystem is buggy. So they like some sort of thing that we can point to. So this combined measurement using this toxicity tool gives us, it works on static code analysis. So the individual metrics can be configured. We're using them straight out of the box because previously we weren't measuring anything. Measuring something is better than nothing. And as we get better at it, we'll start measuring more. That way we'll have this historical perspective of, what our tool set is doing, how our code base is written, and it helps us along. We're trying to refactor the top 10% of our most popular classes. that's our stated goal. Just because we believe, 10% is a nice big number. It covers a nice series of pages, and the end user will notice it right away. We've definitely made some improvements in terms of the projects failing, the unit tests. We removed defects, things like that. But because of this focus on the quality of the code, we've actually improved our page load times. So now we have code that the customer's using. We have unit tests for them, and so the quality is getting better. They can add more things to them, and you'll start to see a nice distribution of the customers using it the most. That's where all of our, we call them evolution projects, are coming from, where they're requesting features and functionality into that top level of that distribution, the stuff that they use the most, the things that they want to improve. And our code base now has a significant number of unit tests to take care of that. And then over time, we'll start fixing things, kind of off that curve, and the unit tests and the metrics will start pointing us to classes that are not as popular as they are right now, but we will get there. So that's how we're going about finding out what we need to create tests for. And next part, we're going to go down to code. I'm going to share some code where we're going to look at specific instances of what we're going to refactor. We've had, like I said, our project was written over 8 years ago, and it was written by contractors who were not looking for code testability. So there are very, very specific things that they've done that we need to remediate now to make our code base more testable. So we're going to talk about hoisting static methods. There was a lot. The project is a J2EE application, and there was a lot of so-called helper classes that did various things, such as look up. It's in the medical field, so we have like provider information, for doctors and hospitals. So we have a lot of static methods that will do certain functionality. That functionality is do the JNDI lookup on an EJB. It'll take the EJB, make some calls on the EJB, and then return you the values. From a client perspective, the client caller perspective, that's nice, but from a testing point of view, static methods pose a problem because you're in your test environment, and if you're making or you have code that makes a call to a static method that does a JNDI lookup, you're getting errors in your test, and those errors are not related to the test per se. They're related to the environment it's running in. There is no JNDI lookup in the test environment that we're using. I know there are multiple solutions to this. One is you can use a JUnit framework that runs in your container, and you're testing. I believe somebody brought it up last time, and you can run your tests in your container so that it can test it in a native environment. So you can do the lookups that you need. You can connect to the database. You can do all those sorts of things. Your code will run functionally the same as it does as in a deployment environment. For our project, we chose not to do that because we call that our end-to-end regression test. If we're running our tests, unit tests, in an environment that's up and running, that environment needs to be configured, that environment needs to be installed and maintained. Our database is quite large, and I'm sure you've come across this, where you can't recreate the database in a consistent fashion across multiple environments and keep that static. So your tests, if they're relying upon data, are not really working on a nightly build, weekly build, deploy scenario. So what we've chosen to do is have all of our unit tests run in a local environment, no database. We're using straight JUnit. We're mocking out any of our dependencies. So we don't have to run in a fully realized J2EE type scenario. So what we have is a series of the dependencies, the database, the JNDI lookups, the other EJBs. We have interfaces for them, and we just use the mockups to handle that. So now our tests, we write tests for all existing functionality that we're going to change. We're not changing the end result of the unit test itself, meaning, the code that we're going to test in a specific EJB or a servlet that calls EJBs. We're not changing what it does, but we're changing how it does it, because we're going in to make the code more testable. So in order to have a baseline, we need to write a unit test before we even begin this process. And by unit test, again, we talk about JUnit, testing the code in isolation with mock dependencies. In addition, we always have a corresponding regression test, which goes in through the browser and uses Selenium. We have our own framework built on top of that to drive the browser to test the scenario specifically. I talked about databases and data environments. We know we have an issue with keeping the data in our development environments in a static state. We have 200 plus developers using a database, individual projects in 4 different regions working in parallel to support one deployable application. So the database itself is never in any known state. Our regression end-to-end tests run, but we have, at this point, no way to rerun them unless we fix up the database before we do that. So we take our end unit tests, we don't include them in, I said before, our JUnits are first-class citizens in the project. They're refactored, they are maintained, they are just like they were regular product code. Our end-to-end regression tests are used to produce artifacts that we can turn over to the client to say, we've done these various things, here it is working. But we don't maintain those. We maintain the functionality, but we don't maintain the data associated with those tests. So at this point, they're kind of one-offs. Until we get to the point where we can recreate the database in such a manner that it would run with the same data that is predictable and static for our tests, it's not practical to maintain the regression, end-to-end regression tests at the same level.
Hey, Ken, when you get a moment, Peter Kofler has a question in the chat there when you see a natural breaking point for yourself.
Okay, toxicity.
And just to repeat that question for the audience, Peter was asking if that link was the toxicity tool that perhaps you were referencing.
No. There's one.
Or if in fact, if you guys are using some IBM tools for some of those reports, or at least for the core versioning capabilities or work item tracking, so to speak.
This is the, I think I just did that to Roger.
I'll repost that, yeah.
Oh, okay. This right here is the tool that we use. I know our architecture department is pushing. I saw Jazz, I saw RPE come up as product names. I know that's what we're moving to. I know we're installing Jazz, and I forget the exact components. I know that the publishing engine is there as part of whatever we're deploying, and a whole series of other tools in the IBM suite to handle a lot of this. And I believe Jazz has built into it version control. and we're going to be using that as well. So I'm assuming all of these tools are either included in there or can be as well. But the
That's right. In fact, I have a link up earlier in the web chat that actually showed one of the dashboards within RTC. I think that one just showed like the number of work items over time kind of thing, but there's a nifty little chart there and several other tabbed dashboards that are available or could be created that would reveal the volatility or toxicity reports.
Yeah, I know some of that stuff is there because we've had the meetings about that. We're in the process. I believe we've actually purchased it, and then we're starting to deploy. It's just that the project I'm working on now, this is what we've chosen to do. And I'm sure we can incorporate all those results as we move forward. So let's see, where were we? Hoisting static method. So we have a series of helper classes. I'm sure you've seen this where you have a static method. In our case, like provider services, dot get the current provider ID or whatever you're working on. And those calls generally using some sort of facade type pattern that would wrap up a large chunk of boilerplate type code in them, but you can't test them. So you write a unit test to perform an action on a struts action, and all of a sudden you're failing because your environment isn't working properly. So we came up with the way, and obviously this isn't something we invented. This is just the way we go about implementing the pattern to forward the calls to an interface. So if you have a series of calls in your code that are static interface, static function calls from another class, we generally, we haven't come across the atypical example yet, but we generally create an interface that lists the methods that we want to hoist out of this. We put them in a new class, and that allows us to mock, and we'll go through this in the code in a few minutes, that allows us to mock out those calls at JUnit test running time. And then we create a class we call a default, which will actually just do the static method call in regular code, so that when you do a build and you deploy, the functionality is the same, but you now have a class that is more testable. And one of the reasons why, because this came up in the beginning when we started this project, why don't we just do them all? We have large sections of code which are generated via a tool, using XML files to drive various things. And one of the things we've done is on a subsystem basis. We chose our first subsystem, which is generally used only by ourselves, not the client, and we've started generating some of these forwarding interfaces in addition to the existing EJBs and the proxies, so that we don't have to write the code in the future. So it is we've implemented the pattern, and now we're kind of standardizing it in a tool set so that we don't have to write the code anymore, because we've proven that it works and we have these types of things in production. So with that said, we'll go into some code so you can see exactly what I'm talking about, because I'm not sure it's not 100% clear at this point. Okay, so here are, generally speaking, we would have some sort of action, struts action, whatever, has a method in it. We're just using client action. You could pretend this is any framework that you want. I was just trying to make the sample code as concise as possible. And we would have things like this. The one I called is message services. It's a piece of code that would do something in a friendly manner for you, the caller, and it exists. We have, like I said, generally speaking, they would go in and do a bunch of calls. I put it for the comments. You know, it would do a JNDI lookup. It would wrap a series of exceptions, perform logging. It would perform debug, you know, enter the call, exit the call, here's what I called, here's the JNDI name, you know, a large series of steps to help debug the application. It would include timings and things. And if you ran this in a local development environment with JUnit, you would get errors because you're not in a server. A lot of the infrastructure that you're looking for just doesn't exist. So if you went to write a unit test to actually call this, the entire unit test would fail to run. We talked about last time the difference between a unit test failing and a unit test failing to run. A unit test failing to run is broken in that there was exceptions being thrown or something completely unexpected happened that caused it to fail. Whereas a unit test failing is the unit test runs in its entirety, but the assertions or what you were trying to test did not function properly. And our rule is every unit test must be able to run when we do a build. After the build, we run all the unit tests, and if a unit test fails, we need to figure out why it failed. We don't have a hard and fast rule with every unit test must pass, because there are instances where a unit test will fail until other pieces of the project are put together. And as long as we know about them, we don't want to, you know, wait or go back and refactor code in stages because we know where we want to be in the future. So we'll just say, okay, by the next build next week, that piece will be in it, and we're good. So we're using some sort of common sense. So given this type of client code, you can't run this in the unit test. And this is the biggest issue that we've come across because, like I said, a lot of our code was generated with a tool, and the tool made liberal use of templates that use this static method, facade type pattern to wrap up various calls to and from EJBs and database. So in order to get around, you know, in order to make this actually testable, we had to do some things. We could see we have 3 calls: connect, send message, and disconnect. So one of the first things is we create an interface because that's what we're going to have to use. And the interface contains the methods and the parameters and returns the things that the static method did. We're using this as our shim. You can see we use the, in our case, we use the I prefix for our interface, which goes against Java coding conventions, but in most instances, you know, we already had a class called message services. We couldn't change the name of that class without affecting a lot of code in the rest of the project. Because, like I said, ours is broken up into subsystems, and while you're working on one subsystem to standardize and bring it up to spec with some unit testing, you have other subsystems that are using the same code, but you don't want to change them at this time. So we broke rules with the naming convention because it allowed us to introduce a new interface with a consistent naming pattern. I mean, we could have come up with something else, but we chose to stick the I in front of it. So now we have an interface that we can use to make these function calls. And if we look at our action now, barring the name, I just put a 2 on it so we can have both. What we've done is we've changed the calls, you can see here, to use this interface in the code. So we've now taken it, modified the code under test, injected the interface that we need into it. The code now uses it to make the call, and everything should, in theory, be correct. In our particular case, you can see here, the default constructor assigns one that we call the default implementation. The default implementation implements the interface that we've just created, and it really just calls through to the static classes right here, here, and here. So the default implementation of this interface is equivalent to the existing call. I mean, it's a little slower in that we have one level of indirection because we're making, a wrapper around it. But it gives us the ability at this point to do the second constructor and inject that interface into the class. We've done this a lot with struct actions and what we call enhancers, which work within our struct actions within a framework to modify the data before it gets rendered on a page. So we can inject this into the class so we don't have to break anything else. So normal code path would use the default constructor, and it would use the default implementation, and the function calls would then go off exactly as they would have before. In a test environment, we can use the second constructor to inject in any dependencies and take it away that way. One of the things that we also did that I didn't demonstrate here is per dependency. We started by going, well, let's create an interface for all the dependencies on this particular class, and we would implement it in the class. We'd have these classes all embedded in there because the code then was isolated. We were, wary of making large global changes. So now the code was isolated into the single class that we were actually testing, which was good because we didn't have anything propagating outward. It was bad in that we soon quickly found out that we had multiple dependencies. So yes, in this example, it's message services, and in our real life world, it was provider services. We had this thing called common services, reference services that people were creating or had created, and a particular action depended upon multiple instances of it. So we quickly found ourselves, by using this isolation technique of keeping everything into the one class using inner classes, we found ourselves writing multiple implementations of the same thing for different classes. And that should be definitely one of the first lights to go off when you start writing the same code 2 and 3 times, that you're in need of a different way to go about this issue. So what we did is we started creating these interfaces for the entire list of methods that these helpers, these facade objects, were providing for us, and then had the existing facade then go off and use or implement that. So that gave us our default implementation that we could use in various places. But we weren't introducing more duplicate code because we had multiple implementations in multiple files. We had one implementation in one file that we could reuse in various places. But the key point is that we have the interface that is being used. So that gives us what we need to do. If we look at our unit test, we can see here is where we just then go off and create that, just like before we talked about using JMock to create mock instances of various objects. So in this case, we mocked out the interface that we just created so that we could hoist, used to hoist our static calls out of our action. Now we can just pass in the mock interface into our action. We can set up a series of expectations, and we can run our test. Now, previously, we didn't have any mock service, any mock service class or any mock interfaces. We would just set it up and we would call. And if your JUnit was not actually running in a server-type environment, obviously the JNDI lookups would fail. The unit test would fail to run. So now that we can mock out these services, so we have a dependency for various things, they're gone. And you can see, we just set up the expectations. For this example, it's doing connect, send, and disconnect. And when we run it, it works. The unit tests will run. and you can handle the pass-fail scenario after the fact. So the bulk of what we're doing in the existing project is creating these types of structures so that we could write our unit tests for the existing code. Is there any questions?
Well, let me go ahead and open the lines then, Ken, because we do have about 15 minutes left, so give me just a moment.
All participants are now in interactive talk mode.
Okay, the lines seem to be pretty quiet, so I'm going to not mute everyone's line, but if you do have a question now, go ahead and ask it. Just in case, if your line is muted, if you're talking and you're not hearing anybody respond, you would hit *6, and you don't have to do that. I don't have to do that, but other members on this call may need to do *6 to come off of mute.
Well, I can ask or answer Peter's question, because he'd asked, did you try to automate the introduction of the indirection interfaces? And actually we have. Like I said, we have a tool that we use to generate large portions of our data access layer. So the EJBs, the interface to the EJBs themselves were actually generated. So introducing code into this tool, we created new templates because we were generating some of the methods anyway. So we do generate the interface itself, the default implementation, and then go off and generate the EJB methods to be implemented, by the developers. Because you said you have 1,000 classes depending on singletons. This is exactly, what we have. We, have 10,000 classes in our application that we needed to go through, and it just wasn't possible to look at all the classes. There's just way too many of them. So using a tool that we wrote, it wasn't available, we created these interfaces. We chose one subsystem, like I said before, that the company uses internally, that the client does not see, as our test project. We generated everything, the default implementations, the interfaces, and we implemented it, which was great because it saved us a lot of time. But now that subsystem is done. The other subsystems are underway. It gives you the ability to write unit tests themselves for mocking out actions and such. I mean, there's code out there that we've re-implemented to help mock struts actions. Because, again, you're not running in a container, so there's various things that you need to take care of within a framework. And obviously, struts is not a framework we wrote, so we didn't have the opportunity to generate anything for that. So generating the code was very helpful because we can go on a subsystem by subsystem basis and have what we call testability built in at that point.
And there is some interesting work done around some patterns-based engineering where, if you reverse engineer this code and create a model, there's actually ways to take apply a pattern to a series of classes, for example, and generate elements from that. And that's pretty nifty ways to do some automation there. I can find that link to some of that work that Daryl Schrag has worked on before. That's pretty cool stuff. But
sounds great.
And then the other thing that I mentioned in the chat was this whole green hat piece, which is another acquisition of Rational fairly recently, where you mentioned that, gee, sometimes we don't even have the servers or don't have access to those servers, or maybe they're still being developed. How do you incorporate that into your unit test? And Green Hat is a way to kind of stub out, if you will, pieces that your application needs to talk to, and provide a simulation mechanism to, on the response, so that you don't have to make major changes to your code. but still run your unit test and get those simulated responses back.
Exactly.
And that is also good for if you're doing like credit card transactions, where sometimes those systems you need to, you get charged per usage. So, in something like that, you can stub that out and simulate the response before you actually go live and start spending the money on, testing transactions. So that's pretty cool stuff. Anyway, the lines are open for questions.
Hello.
Yes, hello.
This is Peter speaking. Thank you for answering my question. So I'm still not sure. You generated part of your system anyway, and so you changed the template of the generation to add these interfaces.
Yes.
Okay, so it was probably easy to just change the template and get the extra interfaces.
Yes, I mean, we were generating the EJBs, the method calls themselves, because we were also writing proxies. So our web tier kind of wrapped the errors. So we had this proxy code that was being generated, and we just, in essence, generated yet another one, but it would be an interface, because that's how we defined them. If you're going to do it by hand, I'd let Roger address that. I mean, I think he just talked about applying some patterns over a series of code to start extracting these things. I believe there's got to be a way we can do it with the tool sets we have today.
Okay. Yeah, I'm trying to find the link to Daryl Schrag's work, because he's done a lot of stuff that more involves like messaging, passing and taking content that's in the model, a UML model, again, which that can be extracted from the code. So, and then iterating through that to produce these templates. That's pretty cool stuff. So. Thank you, Peter.
Because the idea is quite cool, and it would be able to apply it in a generic way. So just find the singletons in the source and mark the ones you want to be replaced, like large-scale refactoring. And nothing can go wrong. It's just a technical change. But that would would be a tool that I would like or need, in fact.
Yeah, but I mean, one of the things that we started with was using this naming pattern. So if you have a static class, I would say 99.9% of the time, people are referring to the static methods using the same pattern. So for us, it was easy to determine the number of callers. I mean, you could do this in RAD right now. You just look up the references to a specific method, so you can get the specific points that people are calling, and then just coming up with a syntactic way to get around that. And one of the first things we did, it depends upon, we were generating stuff now, but in the beginning, we were writing the code. So our pattern was the name, the variable that we were using for our interface in the client code was the name of the class with a lowercase in front of it. So if you had provider services, capital P, capital S, make a call to a method, we changed that to provider services, lowercase p, which would be the variable, the member of the class that we then have this interface on. So, I mean, depending upon how many methods you have, you would define your interfaces and then just do a kind of a search and replace. We would do it on, like I said, we started with a single class, kind of keeping everything contained, doing it within that, but it was simple enough that we get all of the changes in, just keeping the names the same.
I see. That sounds reasonable. That's possible, yeah. I will try. Another short question. So I saw that you introduced a second constructor that is only for the purpose of testing. Did you have any problems with that? Because usually, so it's discouraged to add production code only for the sake of testing.
We didn't have any issues because in our framework, we know that the default constructor was used. So this was literally the only class being used, or the only way anybody would construct it with the dependencies would be us in our unit test. If there was found to be an issue, perhaps somebody else was using it in some way, which we were sure we weren't, because we were creating these interfaces, so they didn't even exist before. We could have went with some sort of container to do the injection for us, to give us more flexibility. But we, last week, I don't know if we talked about, or I intended to talk about using Juice, because we use Google Juice now to do some of the dependency injection, because it's lightweight, and you can change that around. So if you don't want to mess with a constructor, you can use property injection or something along those lines.
Thank you.
Okay, I am putting a little link in the chat here about the patterns-based engineering work, and this is one of a series of developer works articles based on that. I'm not finding the one that specifically I'm looking for, but I figured just let me get that information. You all can continue to do some searching on your own there. But great. Any closing thoughts there, Ken, on your resources in the last 4 minutes we have?
No, other than, like I said, the Graham Brooks blog introduced the terms toxicity and volatility to us, which was great. And we definitely there's the XUnit patterns website to kind of, give a name to various things that you're doing. So definitely 2 good resources to start looking at.
Excellent. If you just want to, well, actually, you can leave that up. Any other remaining questions in the 2 minutes we have left for today? Again, we do have another part in this series coming next Friday, same time, and content for this session will be posted on the same Developer Works page. Going once, twice, 3 times with that, Ken. Once again, I thank you. This has been a very good educational session on your designing for refactorability. Appreciate that. And with that, I'll close the webcast out today. Thank you all for attending. And Ken, if you can pass control back, I'll close it out. Or I'll just grab it.